I put 0 into the function for x, what do I get out? And what's the point?
0, 0.
0, 0. Okay, right there. If I put 1/2 in, what do I get out? 1/4. So my point is 1/2, 1/4. That's probably not going to graph with this fat marker on that graph. So we're going to skip that one as far as graphing. How about when I put in negative 1/2? Still get 1/4. Negative 1/2, 1/4. How about 1? We get 1, so it's 1, 1. How about negative 1? 1, okay. So that's negative 1, 1. It's over here. 2? Over 2 of 4. Great. And negative 2? Still 4. Over 2 of 4. Okay. And 3? Negative 3? 9. Quick question. If you put in one of those negatives and got a negative answer out on your calculator, what did you do wrong? You didn't put it in parentheses. Right. You have to put it in parentheses when you square it, or it's going to give you the wrong answer, okay? So I'm going to connect my points. And what is this shape called? It is a parabola. Yes, that is a parabola. What is the domain? What are the x values in this function? Now, it doesn't mean what's listed here. It means what can I put in for x? Anything. Yeah. What can I not put in? Nothing. So my domain is all real numbers. And there's a short way to write that. It's an R with like an extra leg. That's all real numbers. Any real number can go in there. I can put in 2. I can put in 2 million. I don't really want to graph that, but it can go into that function, can it not? Can I put 2 million in if I just really wanted to? Because I love 2 million. Okay? How about the range? What's going to come out of that problem? Only positive numbers. Well, and 0, right? So my range is that y is going to be greater than or equal to 0. Lots of ways to write that. You can write it like that, it's just an inequality. Or you could say that it's going to start at 0, bless you, and it's going to go on to infinity. If you wanted to be really fancy, you could say that the range of y such that y is greater than or equal to 0. The set of y such that y is greater than or equal to 0. Okay, 3 features that you noticed about this graph related to, and explain how it relates to the equation. So what's one thing that you noticed? You notice nothing? It curves up, okay? So it opens up. That's one thing. It opens up. What's something else that we noticed about it?
The points are farther and farther apart.
Okay, the points are getting further away from each other. That could bring us to a third thing. What about each side of it? It's symmetrical. Yeah, I could fold it in half. Exactly. It would match. Maybe not this one that I've drawn, but yours probably would. And definitely the one you calculated. The minimum point is called the vertex. What are the coordinates of the vertex of this parabola? 0, 0. That's your minimum. And then the imaginary line that goes through the vertex, cuts the parabola in half, is called the line of symmetry or the axis of symmetry. What's the equation of the axis of symmetry? What is the equation of this line right here? Close. Remember your exercises. This is y equals, this is x equals. Y equals x equals. X equals 0. So your axis of symmetry is that x equals 0. Alright, now, second page talks about some transformations. We haven't done this year, but it's done in the past. We've done some of them this year. We're going to talk about vertical shifts. We've already done some vertical shifts. If I wanted to shift the graph of the parent function up 2 units without changing its shape, what would be the equation of the parabola? Just want to move it up 2. What would that equation be?
Y equals x squared plus c.
Exactly. So what would be the coordinates of the vertex here?
0, 2.
0, 2. What's the domain? Right? All reals. How about the range?
Greater than or equal to 2.
Why not 0?
Because it started, the vertex isn't at 0, 0.
Right. And if it's opening up, what's the vertex called? The minimum. So the minimum y value is 2. So that means everything else has to be greater than or equal to 2. Exactly. Alright, so what will the graph of y equals x squared minus 3 look like? It's going to move down 3 from the parent function, right? Okay, graph it here. You see what it looks like. Graph it in that empty spot there. You can use your calculator if you want to graph it and just transfer it from your calculator to your paper. Have it graph? What does it look like? Same, except moves down 3. Yeah. What's the line of symmetry for this parabola? X equals 0. Okay. Now we're going to talk about reflections. Which last week we talked about C and D moving that parabola up and down, left and right, whatever. We're going to start talking about putting something in front. That A What do you think the equation of a parabola would be? If it's the same size and the same shape as the parent function, the only difference is it's flipped. What would that equation look like? Y equals negative x squared. Put that in your calculator or graph it on paper, whatever, and see if that's actually the same thing but flipped. Or you can graph it on your dry erase board if you don't use paper. Alright, did it look the same, just flipped? Good. Okay, so let's look at these. Graph these without your calculator. Then use your calculator to check and adjust your graph if needed. So you've got a negative x squared plus 6. What do you think this one's going to look like? Negative x squared plus 6. It's what? It's going to open down. So the vertex is going to be what? 0, 6, and it's going to open down. Okay, what about this one? Open up. Vertex will be where? 0, negative 4. Okay, try it and see. Get those graphs. Alright, on this first one, open down. Just like that. On the second one, looks something like that, right? Now let's talk about vertical stretching. Look at part C. Yesterday you had to graph the parabolas all on the same coordinate plane. You notice some of them open wider or more narrow than others. Okay? So on part C, graph all 4 of these on the same window in your calculator, but graph them on the different windows on your paper. There's one for A, there's one for B, one for C, and one for D. And then compare each one to the graph of y equals x squared. Get those graphs. I'll give you a couple minutes to do that because you have 4 graphs. Okay, A is the parent function, right? So it's going to look like all the others that we graphed. What happens with B? Y equals 1.5x squared. What happens with that? When I square x and then multiply by 1.5, what happens? Okay. What's going to get farther apart? he says it's going to get more narrow, right? You said it's going to get further apart. You could both be right. What is it that's getting further apart? What points? Which coordinate is getting further apart?
Y.
The y's, right? The y's are increasing more quickly because I just took what was x squared and then multiplied it by 1.5. And what happens on 2x squared? I take what was x squared and then immediately do what? Right, I double it, right? So it's supposed to be at 1, 1. No, now it's going to be at 1, 2. Or it's supposed to be at 2, 4. Well, now it's going to be at 2, 8. So the width of the parabola, if this is my parent function, the width of the parabola is going to come in a little bit because those y's are increasing at a faster rate, right? Because I just doubled it or tripled it or whatever, okay? So what's the difference between y equals x squared and y equals ax squared if a is greater than 1? What's happening? What's the difference between those two graphs? Okay, that's the y. What's actually happening to the graph? It's getting more narrow, okay? Now check out y equals x squared, y equals 3/4 x, y equals 1/2 x, y equals 3/2 x equal x squared. Draw those graphs and see what happens, because on one of them a is greater than 1, but on the other two a is not greater than 1. It's between 0 and 1. See what happens on those graphs. Okay, what seems to be happening to these? If y equals x squared is here, what happens to 3/4 x squared? How does it compare to the original? It's wider, okay? Because what should be at 1, 1 is actually going to be at 1 and only go up 3/4, right? And what should be at 2, 4 is actually going to be at 2, 3. So it's going to open up a little bit wider. What about y equals 1/2 x squared? It's even more wide, because what should be at 1, 1 is now at 1, 1/2. What should be at 2, 4 is now at 2, 2. So it would be even more wide out here, right? So what's the difference between y equals x squared and y equals ax squared when a is between 0 and 1? What's the difference in the graph? It's wider, okay? The graph is wider. Can you tell me why in your own words? Why is it getting wider instead of being exactly the same? Why does it go out instead of maybe going up like the other one did? This one's going out. Like the bowl is getting bigger.
Points are getting closer together.
The y values are getting
Yeah.
closer together? Why are they getting closer together?
Because they're getting smaller.
It's decreasing. We're only taking a part of it, right? It's a fraction, right? Aren't those fractions? Are we taking the whole amount when you multiply by a fraction? No, you're taking a part of the amount, right? So you're only getting part of it, a fraction of it. I want you to finish graphing. I want you to do 2x squared minus 3, 1 half squared, negative 1 half squared plus 3. I want you to do those two. And then the back, putting it all together. I want you to do all 4 of those. Okay? All 4 of those, putting it all together. No, you haven't done.